So welcome to June. We're into June. It definitely feels a little different to be finishing off the school year with our online teaching, but I hope that you guys are getting excited and feeling like the end is near. So just a couple more weeks of new lessons, new work, and then you guys will be free. So here's the plan. This week, I'm just going to start with this pattern practice, and we're going to get into more stuff on linear relations. So today's going to be direct and partial variation, and then we're going to go into writing our own equations using that rate of change and talking about starting point, which has to do with the direct and partial variation from today. Okay, so that's kind of where we're going, and that will probably take us to the end of the year. Okay, so if you just want to copy these down, I just thought that we would do a little bit of some pattern practice, okay? So the challenge is that write 3 numbers after each of these and then email or Edsby message me, okay? Just with these, and I'll let you know. Okay, so that's those. So today's lesson for Monday, Tuesday of this week is direct and partial variation. So the worksheet that I'm going to send out will actually have all the information that I'm going to put up right now, okay? So if you're able to open that first and follow along, if you can print it off, great. If not, you can just write it down and make your own notes. I'm going to write the information here as well, okay? But if you print off the first, believe it's the first 2 pages, from that, then you will have all the information in front of you. Yeah, the first 2 pages. Okay. So we're talking about direct and partial variation. So we're talking about linear relations, right? So linear relations is when your rate of change, like whatever's changing, whether it's your speed or whatever you're doing versus time, your rate of change is constant, okay? And when you have a constant rate of change, you get a straight line. So it's all about linear relations right now. Okay, so direct variation, just to give you a definition. Okay, so definition is that direct variation always, so this is on that first sheet of the handout, always has a starting point of 0. Okay, so that's kind of the key thing right there. In direct variation, it's a linear relationship. Okay, so this year, grade 9, we cover linear relationships. Next year, you will cover quadratic relationships, where the rate of change actually changes over time. But right now, we're just going to cover linear relationships. So it's a linear relationship, so just put in brackets, rate of change is constant, okay? So it doesn't change, always the same. So that's your definition. So we'll give a few examples of direct variation. So an example would be, let's say you're making $12 an hour to shovel. Okay, so this is an example of direct variation because when you start out at time 0, when you're shoveling, you haven't made any money, right? So you're starting at 0. So starting point, and for now on I'm going to use SP, is 0. Okay, so that's kind of the key thing you ask. If the question's asking you whether it's direct or partial, you need to think about where you're starting from. Okay, another example, 40 baskets of apples picked in 2 hours. Okay, and it's direct variation because when you start picking, you have 0 apples. So starting point is 0. Okay, and last example, these are all on that sheet. A rocket rises 20 meters per second Okay, and you're starting at ground zero, so starting point, SP starting point, is 0 meters. Okay, so that's all direct variation. So those are all examples of word problems. When you have this graphed, put it on here. When you graph something that is a direct variation example, your starting point is 0, so you should be able to guess right now before I draw where your graph would start. Doesn't matter what the graph is, if you know it's direct variation, it will always hit the origin. Okay, so starting point equals 0, and again, this is direct variation. Okay, so we've done a couple word problem examples of direct variation, graph example of what it would look like, and then lastly, a table. So let's say we have time and distance, and our time is going up by 2's. Okay, say that's in minutes, and our distance is going up by 4. Okay, because at time 0, your distance is 0, then you know it's direct variation. Okay, if you had a table, well, I'll give you an example when I get to partial variation. Okay, so that's the information about direct variation. Now to go over partial variation. So today is all just really about understanding the difference between direct and partial variation. Okay, we'll start writing and putting together equations in the next lesson. So partial variation. Okay, so definition. The big thing is that the starting point is not 0. Okay, anything but 0 is partial variation. It is also a linear relationship. Just like the direct variation was a linear relationship, this also is a linear relationship. So therefore the rate of change is constant. Okay, so you'll have a straight line when you graph it. The first differences will all be the same, right? It's all going up by the same amount. Linear relationship, but this time it's not going to start at 0. Okay, so let's get some examples. We'll start with our word examples of partial variation. Okay, so let's say there is a golf club. It charges $250 plus, let's say you're going to rent it out for an event, plus $15 a person. Okay, so in this case, let's say you have 0 people coming to your event. Your starting point is $250. Okay, so because your starting point is not 0, okay, so starting point equals $250. Because my starting point is not 0, it's partial variation. Okay, so that's example number 1. Number 2, let's say you have like a hot air balloon and it's 500 meters off the ground. Okay, and it's falling at a rate, so there's your rate of change, at a rate of 5 meters per second. Okay, also example of partial variation because you're not starting on the ground, right? You are starting up in the air, so your starting point is 500. So starting point is 500, and because that starting point is not 0, it's partial variation. Okay, number 3, so what does that look like with a graph? Okay, I'll draw the example from the handout just so you see what that looks like. Okay, so this one, it's drawn all 4 quadrants. So here's your y and here's your x. And here's our line. Something like that. Okay, and this is, of course, the origin. So if the line was going through the origin, you would have direct variation. It is not going through the origin, so therefore it's partial variation. Okay, more than not though, your graphs are not going to involve all 4 quadrants. I'll draw just a mini one down here. They will involve just the positive quadrant. Okay, so examples of partial variation, the lines could look like that, would be partial variation. Draw a couple examples. You could have a partial variation like this balloon one is starting at 500 and it's dropping, so that would be looking more like that, would be another example of partial variation. And anything else. It could be a very shallow rate of change. Okay, so straight line, because it's a linear relationship, but as you can see, here's my starting point, not at the origin. Okay, not at the origin means that it is partial variation. Okay, so really today's lesson is just about distinguishing between partial and direct variation. We will use it a little bit more in the next lesson. So here's your word examples, here's your graph example. I'm just going to give you a table example of partial variation. Okay, so let's say again, our table is time versus distance. So at time 0, and let's say we're going up by 1 hour, and this is going up by 2. Okay, so here, first I'm just going to talk about the first differences. Okay, we talked about 2 weeks ago, I guess, the first difference is right where you subtract that second one minus the first. This would be 4 minus 2 equals 2. And then this would be 6 minus 4 equals 2. Okay, and so on. So all my first differences here are going to be 2. That tells you it's a linear relationship. Okay, that is a rule that you should remember. If you calculate your first differences and they're all the same, you have a linear relationship. Okay, but now what we are talking about is whether this is partial or direct. At time 0, my distance is 2. Since it's not 1, this is partial variation. Or sorry, since it's not 0. Okay, 0, 0 would be direct variation. 0, anything else is partial variation. Okay, so that is what I wanted to cover for the lesson. You have a sheet, okay, it's got a few pages. The first is just the information, and then it's got some examples. So the third page of that, after you go through the information, the third page is just looking at word examples, graph examples, and table examples, and figuring out whether they're direct and partial variation. Okay, so I'm going to leave that for you guys to do, but what I will get you started on is the questions where it says, so we'll do this. It's got a little picture of a car. This is kind of like the bigger part of the worksheet, okay? So the question says, a rental car costs $50 a day plus 20 cents, so it's 0.20, 20 cents for each kilometer driven. Okay, so that is the starting point. So question A says, state the 2 variables. So 2 variables. Okay, so you look at this and you say, well, one of the variables is going to be the cost, right? That's changing, okay? And the other part of the other variable will be how far they drive, okay? So you could say distance and cost, I would say. So two variables. Distance is a variable and cost, okay, is the other variable. Okay, B, what is the dependent variable? So you ask yourself, is the distance, does it depend on the cost, or does the cost depend on the distance traveled? Well, you've probably already said in your head that the cost is going to depend on how far you drive, on the distance. So the dependent variable is the cost. Okay, and of course that makes the independent variable the distance traveled. Okay, so the next part asks you to fill in the table for a rental fee up to 1,000 kilometers. Okay, so we'll make our table. So they've started the table off for you, and this is number of kilometers, and this is the cost. This is another hint too, if you're ever asked for the variables and you're given a table, here are your two variables right here, okay? So number of kilometers, this is going up by hundreds. We have to get up to 1,000. 100, 200, 300, 400. All take you up to 500 and you can keep going up to 1,000. Okay, so the cost, well, we have to look at this. It costs $50 a day and then 20 kilometers driven. Okay, we're going to assume this is all on the same day. So when you haven't driven at all, the cost is $50. Okay, let's say you've driven 100 kilometers. You still have that $50. So we're going to figure out how much it costs to drive 100 kilometers. So we're going to have to take 100 kilometers and times it. So 100 times 0.2, okay, which means 2 zeros. We're going to move the decimal over twice. 1, 2. So that's $20. Okay, so I'm not going to put 20 here. I'm going to add 20. Okay, because I have that initial fee of $50. I have to add the 20 because I've driven 100 kilometers. So my next is 70. Okay, so now we'll do 200. We have times that by 20 cents. Okay, so we oh, I should have, yeah, okay. So this is going to be 40, okay? So what I could do is add 40 to 50, which gets me to 90, right? So I add 40. Be careful that I'm not adding it to the 70, right? Because I've only really gone up 100. Okay, so that's how you could do it. You could do the 200 times it by your 20 cents and then add that to the original cost. Or you can say, well, I've just gone another 100 kilometers and I know every 100 kilometers cost me $20, so I could add 20 here, add 20 here. So you've probably picked up the pattern that this is going to go up $20 each time. Okay, and you're going to go down to 1,000 and figure that out. Okay, so that's part D for the worksheet. E asks you to graph it, and they've nicely put the units on the bottom. Okay, they've done the scales for you. So there's number of kilometers, there's cost. Okay, so you can put your points in. So at 0 kilometers, your cost is $50, and you're going to draw your line. Okay, F asks you, does the relationship represent partial or direct variation? So you could see this, well, 3 ways. In the word problem, it says that it starts at $50. In your table, it starts at 50. And when you graph it, you're also going to start at 50. Okay, so you can see it's all 3. Of course, it's telling you that this is partial variation. Okay, and justify your answer. You could say any number of things, but I would basically just say starting point is 50, not 0. Okay, determine the rental fee for 45 kilometers. I'm going to leave that up to you to do. Okay, you could use your graph or you could use your table for 45 kilometers. Be in there. Okay. Okay, I hope that helps you to get started on the worksheet. There's one more for you to fill in. This is done the majority of the first question, and then there's one more question to do. Okay, so that's it for today. We will start on equations next lesson.